In this video, using only free and open source software, we'll create a digital clone of a physical computer running a vintage Microsoft Windows operating system. Then we'll deploy and run the digital copy in a virtual computing environment and show it running side by side with the original physical system. Many digital systems in operation today are long-serving, but remain essential or even critical to the organizations they serve. In fact, ancient versions of Microsoft Windows running on vintage computer hardware still manage and control industrial machinery, medical and scientific devices, factory production lines, and much more. For example, in our lab we have a Microsoft Windows XP computer system running on hardware that's more than 20 years old. It's a 32-bit x86 system with a 40 gigabyte hard disk drive. Despite its advanced age, the system still acts as a test bed and software support platform for important legacy computing applications deployed in multiple virtual environments. Let's lay out the scenario for the demonstration we're about to present. We'll create a digital clone of the personal computer hardware, its Windows XP operating system, and all its installed software saved as a file. Then we'll transfer a copy of the file to a portable private operating domain, what we call a pod. Working in the pod, we'll use various tools to modify, configure, and test the digital clone and transform it into a virtual machine. We'll verify the virtual machine starts and runs exactly as it did on the original hardware. Finally, we'll demonstrate the physical and virtual systems running simultaneously on the original PC and in the pod. Let's get started. First, we need to check if Windows XP on the physical PC already has the IDE storage device drivers installed that we'll need to boot and run the virtual machine under emulation. The files will be located in the Windows System32 drivers folder. There are 4 of them as shown here. If the required drivers are not already present, install them from a Windows XP installation CD or DVD, or download them from the internet and save them to the Windows System32 drivers folder. If it's not possible to add the required storage device drivers to Windows XP in the physical computer, they may be installed after the virtual image has been created, but we won't be covering that procedure in this video. For this demonstration, both the physical PC and the pod where we want to install the virtual copy are connected to our lab's local area network. We've created a Windows network share in the pod and made it available to the physical PC. On the physical PC, we'll install the Windows sysinternals disk to VHD utility. It's a freely available from Microsoft, but in our case the most current version is not compatible with our obsolete Windows XP operating system. Fortunately, older versions of disk to VHD are available from the Internet Archive, also called the Wayback Machine, as well as from other internet sites. We retrieved a copy of disk to VHD version 1.63 from 2010, which is compatible with Windows XP, and saved it to the physical PC. Disk to VHD does not require installation. Simply save the executable to a convenient folder on the physical PC. Disk to VHD won't accept a UNC path, sometimes called a network path, as a destination for the virtual hard drive file it will create. The path to the folder where the file will be saved must begin with a drive letter. So before running disk to VHD, we have to map the network share exported from the pod to a drive letter on the physical PC. After that, run disk to VHD as an administrator. First, select the disk volumes on the PC that you want to include in the virtual machine image. Next, select the drive path and VHD file name where you want to save the image. Then click Create. This may take a very long time depending on your physical system's processing power, how much data is being copied, your network adapter's throughput, and the speed of your local area network. In the case of the ancient Windows XP system in this video, with a 100 megabit per second network adapter and 22 gigabytes stored on a 40 gigabyte hard disk, creating and saving the VHD file over the network took about 9 hours. If your legacy Windows PC is not connected to a network, save the VHD file to a removable storage device. You can later transfer the storage device to a network computer and copy the file from there to the destination virtual computing environment. We'll use some of the free and open source tool collection found at virt-tools.org to work with the saved VHD file and to create, configure, and launch our virtual machine. From this point on, we'll be working in the pod, our virtual computing environment, connected by the secure shell protocol to a bash command prompt. First, let's convert the image we created with our disk to VHD into RAW format, which is suitable for use with QEMU and easily exportable to other virtual machine emulators. In this case, we've named our image file after the physical Windows PC we are virtualizing. Now let's get some information about the virtual disks, partitions, and file systems contained in the image. We need to ensure that Windows XP will boot in the virtual machine using the IDE disk driver files. We added them to the physical PC before creating the virtual hard disk file. Let's verify they are present in the machine image. Now we need to modify the Windows registry in the virtual machine image so that Windows XP will use those drivers. You can obtain the required registry file from multiple internet locations, but we have a convenient download link for you, shown here. Then we must search the Windows registry in our virtual machine image to find the control set Windows XP will use when it starts. In this case, we can see that the current and default is control set 1, and we need to verify that the merge ide.reg file we downloaded contains entries for control set 1. Then we must merge the settings from the merge ide.reg file into the Windows registry of our image file so that Windows XP will use the IDE device drivers for its virtual disks when it starts as a virtual machine under QEMU and not the drivers it was configured to use on the physical PC. At this point, we're ready to start the virtual machine and manage it from the command line. After the virtual machine starts, you should find yourself at the QEMU monitor prompt. You can connect to the desktop of the running virtual machine using the VNC or Virtual Network Computing program. Launch VNC and connect to the network address of the pod on port 5907, which is the listening port we set on the command line for the virtual machine we just launched. Here we are connected by VNC to the desktops of the original physical system and the digital copy we just created. As you can see, they are running simultaneously and independently. The one on the left is the physical PC in our lab. The one on the right is the digital copy running under emulation in a portable private operating domain. They're functionally identical in every respect. We hope you found this demonstration interesting and informative. We welcome your comments. Please let us know what you think. If you want to find out more about the free and open source tools we used and talked about in this video, click on the link below. Feel free to contact us at xviewsolutions.com for more information or with questions about virtualized computing and your specific needs. We're always available to help. Thanks for watching.